All right, so this is number 6, so it's on part 2 of the notes. And we had gone through, and this is really bothering me. Yeah. Okay, so what this said, but you really couldn't read it because I messed up on it. It was together, because we were looking for tangency and togetherness. Together at the vertical asymptote of x equals -2, right? So that's where your togetherness was. There was no tangency there. So we went through and we found all this. I think y'all are doing okay. You're not having any major problems finding these things. We're good, right? Most of that's a review anyway. So we went down here and we graphed this. We plotted our points that we knew. We only had these 2 points. We plotted our drew our asymptotes. We were able to get this shape of the graph in, and then we knew it should come up like this. But I told you on this one, okay, there's sometimes you'll know when it's going to happen, but on this one that you actually cross the horizontal asymptote, because you can cross asymptotes. You can cross horizontal asymptotes. You can cross slant asymptotes or oblique asymptotes. Vertical asymptotes, no, because that's affected by the domain. The only way that I can think of that you could cross a vertical asymptote is if it was like a piecewise function. Like if I had this and I told you there was like some random point that x equaled -2, then we could put a point on there, and then that's kind of cheating, but otherwise we don't really cross it like we can these others. So the idea of the asymptote that it doesn't cross, it's not really 100% because it's about the end behavior. It approaches this. A function can actually cross an asymptote an infinite amount of times, and depending on what function it is. I would not expect you necessarily in this one without being told to know that it would cross the asymptote. Like you're not there yet to know those kinds of things. But I told you, it does. It's going to come up here, and it does, you know, this is a horizontal asymptote, so it's going to approach this as x approaches -infinity. However, we don't know if it's approaching it from the top or the bottom, and since it crosses, it's going to actually be approaching it from the top for us right now. So I said, how would we know where it crosses? I think it was Zeke that said, well, it's whenever y equals 3, right? So we set this equal to 3, and then we can solve it. So to solve this here, I would multiply both sides, right? So I'm going to get 3 times x plus 2 squared equals 3x minus 3 times x plus 4. And this ends up not being too bad at all in the end. So x plus 2 squared is x squared plus 4x plus 4, right? So I multiply that by 3. That's going to give me 3x squared plus 12x plus 12 equals, and this would give me 3x squared minus 3x plus 12x, so plus 9x. I'll check me here. Minus 12. Okay. Everybody agree with all that? So looks like a quadratic, but it's not. So when I subtract the 3x squared from both sides, they're going to cancel out, right? And then do the 12s cancel out? No, that's tempting though, isn't it? If I subtract 9x over here, I'm going to get 3x equals what? -24. So x equals -8. So that tells me then that this crosses the asymptote at x equals -8. So 2, 4, 6, 8. This is another point right here. Now, we're not going to, like I said before, we're more worried about the shape and those sorts of things. So we're not going to find a bunch of other points to know how high up it goes over the asymptote and that sort of stuff. But it does cross it. It's not a bounce of any sort. So it's going to come up here and it actually hugs the top side of the asymptote. Okay, so I mainly, out of this one, wanted you to understand that it could cross an asymptote. Okay, we all good on that? Okay. Any questions about that at all? I'm going to double check. I've worked the questions. I don't remember off the top of my head. If you are, I'll either tell you or it's not going to matter. Like if I hadn't said anything about this question and I had y'all do it and you drew it and it went up like this, just like that one did, that'd be fine. We'd take it. Because again, it's not something I would expect you to know. There are some on the homework that you will come across that you have to based on the stuff that you have. So that's one other reason why you need to know it's okay. Otherwise, you're going to think you plotted something wrong and it's just not going to make any sense at all to you. But there's a couple that we are going to look at today together where it's more obvious like that. So I believe, yes. So I'm going to give you another part. And I'm doing that. I know we didn't finish all the rest of them, but I think these are a little bit more interesting. I think the basic ones y'all get and you can do. And if you can do the little bit more interesting ones, then you can totally do the basic ones. So I want to look at these. And I like to make the notes in the homework the same color, but I realized this was probably a bad idea in this situation because they all look so much exactly alike. So just make sure that you keep up with the difference so you don't get it mixed up with your homework. And I sent out a remind about the homework. Y'all got that, right? Remember, you have to read my messages. You're not my husband. You don't get to ignore them. Yes. You don't get my reminds. Did you sign up for sure? You know, that happened to me in my own remind last year sometime. What I'll do is I'll kick you out and then re-sign up and see if it works. I don't know. Do you get other reminds, just not mine? Yeah. And you don't get any of them? That's very, very strange. Okay. Yeah. Let me, I'll kick you out and then I'll see if if that works and maybe we'll put it back. But on the homework, so let me say this since she doesn't get them. Number 1 and number 8, you want to change the scale. I'm telling you that so you're not mad after you graph it and realize it doesn't work. I mean, how many times have you graphed something and you're like, crap, you got to redo it, right? So you still want to count by 1s on X. That's very important because some of your roots are really close together, and if you count by 2s, that's going to make everything else very difficult. So keep a 1 on the X axis, but on the Y axis, count by 2s on number 1 and number 8 on the homework. Okay, so make yourself a note if you didn't already do that. Number 1 and number 8, count by 2s on the Y axis so that your graph will work out better for you. Otherwise, one of them goes way off, and then it's just going to be confusing. Okay? We good? All right, 1 and 8. All right, so now, go to the other one. We are going to start with number 7 here. And so this is, what was this? Do I remember? 80? Oh, that says part 1. There we go. It was on page 80. All right, so we're going to go ahead. We'll go through the parts together, and then I'm going to give you a minute to try and get it sketched on there and see if, you know, how you feel about what's going on there. Holes. Does it have any holes? No. And to do that, we look for a unique factor in the numerator and the denominator, right? There isn't any, so this would be none. All right. Do I have any x-intercepts? My roots? Yes. They are what? 0 and -2. Do I have any vertical asymptotes? Yes. How many do I have? 2. So x equals 3 and x equals -6. And those are 2 separate lines. So I do want to say something about this because I did not count this wrong on, I don't remember if it was the quiz or if it was a homework because I graded it all yesterday. If I'm going to say like that x can't, if it's a domain and I say x can't equal whatever, then I can say like x can't equal 5 or 6 or something like that. That's okay. But when it's an asymptote, I don't want you saying like, I don't want you doing x equals 3, -6. Just think about it this way. If you had 2 lines and it was like y equals x plus 3 and y equals x minus 6, would you ever write y equals x plus 3, x minus 6? Like that doesn't make any sense, right? So that's essentially what you're doing here when you do this because they're 2 separate lines. It's not like a list of numbers. It's an actual line. You with me? So make sure that you're writing them out as separate lines because it's just a little bit different notation. All right, let me erase all that so you're not confused about what that means. Like I said, I didn't count it wrong, but it's not really right. So, all right. So tangency and togetherness. So tangency, I look for what? Look in your little radian thing if you need to. Yeah, tangency is your numerator. Togetherness is your denominator. Oh, not your head. Your denominator, right? And you're looking for even exponents. So in the numerator, do I have any roots with even exponents? Yes, I do, right? What? X. So that means I have some tangency. So I have tangency at x equals 0. Does that make sense to you? Just like for polynomials, that would mean that I would have a balance right there. That's what your tangency is. It's just the right way to say it. And then, do you have even exponents for your factors in the denominator? Yes. That means you also have some togetherness at x equals 3. So this is an asymptote. This is a root. But we have tangency and togetherness here. Everybody okay with that? All right. Do we have any horizontal asymptotes? So what's the degree of the numerator? 3. What's the degree of the denominator? 3. They match, so so it's 1. It's the ratio of the leading coefficients. I don't need to multiply it all out to see what that is because I can tell by looking, right? I mean, if I had to actually go find like a slant asymptote or something, I would need to multiply it out so I could go and do that division kind of thing. But I know when I do that, the coefficients of all the x's are 1. So x cubed is this one and x cubed is this one, so y just equals 1. And then, since they equal, there is none for this. What's your y-intercept? 0. If you have a root of 0, your y-intercept is 0. All right. So let's go here. And now I've got to do my number line. So on my number line, I'm going to I have to put my asymptote. So I've got a -6. I also need to put my roots. So that's a -2, 0, and 3. All right. So if I plug in a -7, -7 squared would be positive. And -7 plus 2, is that positive or negative? Negative. And then whatever happens in the x minus 3, it's going to be squared, so we know that's positive. And -7 plus 6 is negative. So overall, what is this? Positive. Everybody okay with that? So then I pick a number in here. I'll go with -3. So that first one's positive no matter what. Then the second one would be what? Positive or negative? Negative. And then the denominator, I'd get positive, what? Positive. So overall, that is between -2 and 0. We'll pick -1. So that's going to give me positive. And then what in the numerator? Positive. And then positive, positive. So then between 0 and 3, I'll use 1. It's going to be positive, 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 positive. Then I can pick 4, and I would get positive, 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 positive. Right? And then this tells me what's happening with my graph, right? Where my graph is negative, where my graph is positive. Okay. So now let's graph our asymptotes. My vertical asymptotes are at -6. And again, you're welcome to use the colored pencils if you want to. 2, 4, 6. That's up to you whether or not. 2, 4, 6. I didn't have colored pencils at home. I was using pen. I decided colored pen was fine for my asymptotes. But I knew I should be using pencil when I'm sketching the graph. And then my other one is at 3. And then my horizontal is at 1. All right, so I'm going to give you a couple minutes. I want you to kind of think through what the graph would look like, plot the important points, use a pencil to draw your graph, because if you're not, if it doesn't work out or whatever, you might need to pick a couple key points, but I want to give you a chance to think through this on your own before I walk you through it, okay? So I'm not going to give you like forever because I don't want you stressing out over it or anything, but I just want you to get some things plotted and see if you can get this sketched. Okay, so that we have time to do another one, I want to go ahead and start talking through this. So the first thing we want to do, we've got our asymptotes in there, then we want to plot our roots and our y-intercept, which in this case, one of them happens to be the same thing. So I'm here at 0, 0, and at -2. And that's like it. It's like when you're on the final puzzle for Wheel of Fortune and they give you one letter. You're like, great. That helps a lot, right? So we have this. This helps us, right? From -infinity to -6, it's positive. So I know it's not down here, right? It's up here, probably above that asymptote, and probably not just right there, but we don't necessarily know that for sure right now. Then from -6 to -2, it's negative. So do we feel like maybe we kind of understand where that part might be? Like if it's negative from here to here, then I'm probably going to look something like that, right? Because it's going to have to relate to this asymptote here. Then it gets positive, right? And remember, we can cross an asymptote. Maybe it goes over that y = 1, maybe it doesn't, we're not real sure. But then here's another root. So I have to decide, is it going to come up and then come back down? But after 0, it's not negative, right? Plus we had that tangency, yes? Right, that tangency, which meant that it's going to bounce right there. So this is going to come up, and I'm not sure how much, but it's going to bounce to stay positive, right? That's how I got that much right there. So now between 0 and 3, it's going to stay positive. But I know it's not going to stop right there, and it's not going to cross the vertical asymptote. It's supposed to continue along. That's why I have the vertical asymptote. It's got to continue along to infinity. So this is one of those where I don't need to tell you that it crosses the horizontal asymptote. You're going to feel weird about it. You're going to be a little unsure about it, right? And maybe, again, maybe it does here, maybe it doesn't. We don't know. And whether you do it or not, I mean, that's kind of irrelevant at this point. But in order for this to continue, because it doesn't just stop, it's going to have to continue up like this. Okay? Does that make sense to you? All right, so now on the left-hand side of this asymptote and on the right-hand side of this asymptote, there's still parts of the graph, right? Because my domain is all real numbers except for -6 and +3, right? And so I have to decide where it's going. I know on the right-hand side it's still positive. So again, probably above the the horizontal asymptote. What I do know is not only do I have tangency, but I had togetherness also, right? And my togetherness was here. And what that tells me is instead of things going in opposite directions, they're going to go in the same direction. So it's coming down like this. Does that make sense? And since there wasn't any togetherness here, it's going to have to come down like this. Does that make sense to you? Like I haven't got the rest of those pieces, but that gives me those things. That's how I know that stuff. Then you can just do the shape, and I'm okay with that, but it doesn't hurt to graph a few points. So I'm going to give you, just so that we don't have to take the time to figure them out. I'm pretty sure if you picked points. I just picked these random points, and none of them come out pretty, I don't think. But I picked -7, 4, and 6 because I felt like that would give me something. So with -7, what you get is 49/20. Right? So that's like 2.5, right? About. So at -7, this is -6. So at -7, it's about 2.5. So it's like right about there, which means that this would come down and look something like that. And again, maybe it goes under that asymptote and then hugs the underneath it. We don't know, and that's okay for right now. Okay. At 4, I got 48/5, which is a little over 9, right? So at 4, I went to 2, 4, 6, 8, 9. Well, my little arrow there is not super accurate at this point, and not the end of the world, right? I kind of go in there and fix my arrow. But I didn't feel like that in itself was enough because I kind of already knew that, right? So that's why I did 6, and I got 8/3. So that's what? 2 2/3. So at 3, 4, 5, 6, I was at 2 2, right about there. And I felt like that one gave me a little better idea. But even if you hadn't picked any points, could you have at least gotten those shapes in there? And again, that's kind of the basic idea there. So do you see how to think through it? How do I know this? Think about where your togetherness is, and that's why you want to sketch lightly in pencil, because my arrow was like not in the exact right spot, but I had the idea. I knew when it was opposite. I knew where my bounces were. It crossed the horizontal axis. You got to learn cross the horizontal asymptote. You got to learn to be okay with that, because I know you probably felt like you couldn't cross them before. You can. Okay, we good? Because what it boils down to is the horizontal axis is really, the horizontal asymptote is really more for this piece and this piece, and these are kind of more for the vertical, so it's just because there's different pieces of the graph. We all good? All right, so probably just have time to really, really talk through one more. Let's see, let's do number 9. Number 9. I wish we had time to kind of work through all of these, or have time for you to think through them. There's ones that are very similar to this on your homework as well. But all right, so in order to figure out my holes, I need this to be completely factored. Now the nice thing is it's already kind of factored for me. Maybe this doesn't factor. Maybe that's why it's like that. Can I factor this? Yes, I can. So this actually factors into x minus what? 4, and x plus 3. And then this is x minus 1. All over x plus 2, x minus 2. I just realized I don't think we've done one with a hole. I know there was one on your notes. I must have skipped over it. But all right, so is there a hole here? No, there's none. Which means nothing's canceling out, so I have 3 roots. They would be -3, 1, and 4. How many vertical asymptotes do I have? 2, so x equals, and I think on here, after I told you not to combine things, but I think combining this is okay. I can't think of a reason why it's not. Because you could kind of do the same thing if it was a horizontal line, so I'll be okay with that. If you write them separate, that's fine too. Just know if you need to write them separate to know there's 2, then that's fine too. All right, so tangency and togetherness. Do I have any factors that have an even exponent on them in the numerator or denominator? No, I do not. So there is not any tangency or togetherness. Do I have a horizontal asymptote? What's the degree of the numerator? 3. The degree of the denominator is 2. It is top heavy. Is there a horizontal? No. So there is none. Is there a slant asymptote? Yes. There is, because the numerator is 1 greater than the denominator, which means that I'm going to have to do some division. In order to do the division, I got to have it all multiplied back together. So I needed this to get my roots, but now I actually need this multiplied in here and this taken care of, right? So to take care of the numerator first, okay, I'm going to distribute this x, so this is going to give me x cubed minus x squared minus 12x. Then I'm going to distribute the -1, the minus x squared plus x plus 12, right? So altogether that's going to give me x cubed. Then what? Minus 2x squared minus 11x plus 12. Good. All over. That's a pretty easy one, right? What's that give me? X squared minus 4, because it's a difference of squares. Okay. Can I do synthetic division here? No. I have to do what? Long division. Okay. The kinds of mistakes I saw on the synthetic division and long division on some of the stuff that I just graded, you have to put placeholders, okay? Now, I don't need any right here, but if this was the numerator, I'd have to put placeholders there, okay? And some of y'all are leaving that off and it's getting you the wrong answer. So when you're trying to figure out why you got something wrong, that might have been something that you had. Now, I know that you may have been taught that you have to put placeholders even in the divisor. You don't really have to. It needs to be if there's any under here. This you don't have to. You just have to make sure you line them up correctly. So I've got x cubed minus 2x squared minus 11x plus 12. All right, so how many times does x squared go into x cubed? X times, right? So it goes in there x times. So x times x squared is x cubed, and then x times a negative 4x. That's why I have to line this up over here. So there's kind of a placeholder there. I don't really have to write it. Then I have to change my signs. So this gives me negative 2x squared minus 7x plus 12. X squared goes into negative 2x squared, a negative 2 times. And then does the rest of what happens even matter? No. So that means that my slant asymptote or my oblique asymptote is x minus 2. Everybody okay with all that? Now, of the three forms that you have here of this written out, which one is the easiest one to get the y-intercept out of? It's a matter of opinion when I say easiest, but I would say the last one. If I do it in either one of these, I have to plug a 0 in for x, then I have to actually do some work, right? Here, if I plug 0 in for x, it just knocks all that stuff out, and I just have 12 over a negative 4, right? So it's a little bit easier that way. Did y'all have a question? You good? Were you confused? You got it? Okay. You sure? Because you might not be the only one thinking it. Oh, okay. Does that make sense? Anybody else wondering that? Why I used long division and not synthetic? When you can use synthetic, you can use either one of them, but you can only use synthetic division if this is a linear binomial and it's not linear. So that's why we have to do it that way. Yeah. And then, all right, so what do we say? It was negative 3? All right, so this is 0, negative 3. Okay. All righty. Then our number line. So on my number line, I put my roots, which are at negative 3, and I have to put my asymptotes, so I need them in order. Negative 2, because it's a number line. 1, 2, and 4. 1, 2, and 4. And there's a lot on there. Okay, so I know sometimes when I'm working them up here, you're just kind of work on your own. Yes, sir. Yes. Do we all understand where my signs are coming from that we're doing this? Yes? Okay, just making sure because sometimes I won't respond. So negative 4. And of this one, to me, it's easiest to look at that middle version where it's all factored out. So if I plug in a negative 4, it's going to give me negative, negative, negative over negative, negative. So overall, that makes it negative. Then I'm going to have to use like a negative 2.5. So that would give me negative, positive, negative, 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 which makes it overall positive. Then I can use 0. That's good. So it's negative, positive, negative, positive, negative. So overall that's negative. Then between 1 and 2, I can use 1.5. So that would give me negative, positive, 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 negative. And then I've got I'll use 3, so that would give me negative, positive, 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 positive. So that's negative. Then when I use 4, I'm sorry, I can't use 4. When I use 5, that makes them all positive. So do you see how this switched back and forth from negative, positive, negative, positive, negative, positive? Is there any way that I could have known that was going to happen before I figured all this mess out up here? Because that doesn't happen every single time, right? If you look back at the last one we did, it didn't switch back and forth. But what did the last one have that this one doesn't? It had tangency and togetherness, right? So if I have tangency, that means at that root, I'm not changing signs. And at togetherness, I'm not changing signs either. So if it doesn't have tangency or togetherness, once I figure this out, isn't it going to have to switch back and forth? Because if it didn't, then I would have some tangency or togetherness. Does that make sense to you? So if it doesn't have either one, it's kind of safe to know that that's going to happen. If it does have either one, I would say go ahead and do that so you don't get yourself mixed up on what's actually happening. But that's just kind of a little tidbit of information there. Unless I've told you that you absolutely have to do it. All right. I mean, you could at least write it out and put it there, even if you don't think through all the rest of that stuff. All right. So let's graph this one together. So we've got, I'm going to start with my vertical asymptotes, which would be at negative and positive 2. And then I have my oblique asymptote, which is at x equals negative 2. So once I get this point, what's the slope of that line? 1. And so I can just go diagonally through my little boxes on my graph. A straight edge is good too, but if you don't have one, you can usually dot that line good enough. But you definitely don't want to just have some weird crooked thing. So I want you to work on this one. How many points can I plot from the get-go? There's actually 4. What else can I plot besides my 3 roots? Your y-intercept. Okay, so get those 4 plotted. I'm going to grab the review and I'm going to pass that out while you try and get this sketched. I'm going to hand these to you individually. Don't pass them out to your neighbor because, yeah, it's not stapled because I just printed them because I didn't get them for whatever reason. And I didn't make them front and back, so it makes it seem even thicker. So again, we don't need to be drama queens about packets. Okay, so I can come over here and I can graph, let's see, I have a point at negative 3, I have a point at 1, and then I have one at 4, and then my y-intercept is 0, negative 3. Okay. I know from negative infinity to negative 2, I'm sorry, and so to negative 3, I'm negative, and then that becomes positive. And I've got this slant asymptote here. Do you think that 1 point is kind of good enough to give you an idea of the shape? Yeah? Okay. Again, I could do this probably way, well, I know for sure, way better with a pencil instead of this pen up here, but something along those lines, right? And then from 2 to 4, I'm negative, and then from 4 to infinity, I'm positive, so I feel like I could probably do that pretty well. So there's my 2 sides. Now this middle is weird, right? Because I got a point on either side of that slant asymptote. Well, from negative 2 to 1, I'm negative, and then I'm positive. And I've got to go through here, right? So I've got to go through my y-intercept and come up something like that. And notice that when you're done, you have to remind yourself, okay, I had no tangency or togetherness, so there should be no bounces, which would be hard to do if you weren't doing it intentionally. But then you got to look at the togetherness part. This is going to positive infinity, which means on the other side it's got to go to negative. And then if this is going to positive, this has got to go to negative. Because if I don't have any togetherness, it's opposite. Okay, we good? We crossed that the slant one. We have to be okay with that. We good? Any questions? All right.